Hello everyone, my name is Wenchen Wang,
And I'm Chan Gun Chai.
and we are going to talk about queuing models. Queuing model is a common phenomenon in everyday life. It is a mathematical method of analyzing and conjunction and delay of waiting in line. A queuing system consists of one or more servers that provide service of number of arriving customers. Customers who arrive may to find all servers are busy, and they may join one or more queues in front of the servers. Queuing theory was created by Agner Erling in 1909. The queuing theory has several processes, which are arriving in a queue, waiting in a queue, and being served in front of the queue. At the first stage, arrival, also referred to as the calling population. The calling population can be either limited or unlimited. The arrival process describes how customers arrive to a system. The second stage, the number of customers wait in the queue for service. There are some disciplines of a queuing system that a servers use to choose the next customers from the queue when the servers complete the service of the current customer, such as customers are served on a first-in, first-out basis, and customers are served in a last-in and last first-out manner. And also priority means customers are served in order of their importance on the basis of their service requirements. Most queuing formulas assume that all arrivals stay until service is complete. Others may call bulking that refers to customers who do not join the queue, and raging refers to customers who join the queue but give up and leave before completing service. The third stage is service represents some kind of activity that take time to serve. The last stage is output. It is about how customers live and queuing. There are some types of business that using queuing systems, such as waiting lines in airline counters, hospitals, banks, supermarket, and etc.
A typical example problem. Pattern of arrives at the system. Usually, customer either arrives from the schedule or else they arrive randomly. Arrivals are considered random when they are independent of one another and their occurrence cannot be predicted exactly. However, there's a problem, which is the frequency in queuing problems. The numbers of arrivals per unit of time can be estimated by a probability distribution. The formula below is to find out the pattern of arrivals at the system. Real-life example. Here's two of the case study. The first one is the banking ATM queuing method. The second one is the restaurant queuing method. Both of them we can use it usually in the real life. Both case study we're going to use different queuing method to finding out how to improve the business. Here is one of the real-life example, a banking ATM queuing method. This method, which can showing how ATM works one-to-one customers. A queuing system can be complete described by the input or arrive pattern. Like the customer come in and they will go to the service, which is the machine, and then queuing this script line, which is getting the money or using the service to find their balance, and then they will exit, which is type of the customer behavior. And here is the example of the diagram how is the queuing system work in the ATM. ATM queuing module also using a marketing theory which is called FIFO, who come first, who serve first. From the queuing method, we can use a method to calculate, for example, the little loss. And here is another example which is called the ATM method, MMI queuing method. The MMI queuing method included the mean of customer arrival rate, probability of zero customer in the ATM, the probability of having n customer in the ATM, the average number of customer in the ATM, the average number of customer in the queue, and the average waiting time in the queue. Therefore, the bank can use this type of method to improve their service on ATM. From the ATM queuing model, it uses the single queue. Here is another two example, which is the multi-server and the multiply queues. For the case study, restaurant queuing module is a tricky one because it can use both multi-server. However, it depends on time. For example, in dinner time, it should be using multiple queues. However, on normal daytime, it should be used a single one. That is the best way for their business. The example of multi-server, the single queue. Customer come in, which is the arrive rate, and they order food using the different server to work on it. For example, drink and food will be the two of the server. However, on the multi-server multiply queues, there's a free queues and free servers, which means the arrivals, which is the customer, we only can choose three of the menu and to direct to the three of the server. Here is the method for using on the restaurant module, which also similar with the bank ATM module. It includes the MMI queuing module and the little store. The queuing model can help restaurants use less time and enough employees to serve the customer, which can help them to increase higher profit and lower the output resource. In overall, both case studies showing our lifestyle is getting much more easy because of the queuing method. Also, increase the customer service, which help to improve the brand image.
There are some benefits and limitations of queuing systems. Benefits are scheduling, and it can be used to improve the customer service, and also can determine the number of checkout counters needed to be secure, smooth, and economic operations of its stores at various times during a day of the supermarket or a departmental store. On the other side, limitations such as it's too mathematical and too restrictive for real-life modeling. And most of queuing models are complex, cannot be easily handled in the complexity of production lines with product-specific characteristics. If the queuing discipline is not in FIFO, the study of queuing problems become more difficult.
Here is the reference for our queuing models video.
We are presenting the technique of queuing models. I am Wenchen Wang.
I'm Chan Guing Chai, and this is the end of the video.